Okay, we're trying a new Everybody Codes mini-series, I guess. Here's day one. What's going on? This looks like Mod Pow. Oh, I see. It's a bit different. Fine. Get how to use the Regex library, apparently. Okay. Okay. 488, 313. Okay. Well, all right. We use the last 5 remainders. Okay. Uh, let's see. Uh, let's see. All right. The sum of all remainders. Mm, we get the sum. Why does it do this? Hmm. Okay, well, how big are these numbers? Hmm, not that big. Oh, wait, yes, they are. The modular was small.
What's happening to this?
Okay, David, please let me do what I'm doing. No. Nice. Okay. So what was going on here? So we're dealing with this function which is similar to modular power, right? It takes a base and an exponent and a mod, but it doesn't actually return like n to x mod mod. Instead, it does something with the remainders. So in part one, you just concatenate all the remainders. And also in part one, the data is small. That's fine. You can just sort of brute force it. Part two gives you bigger data, but it says only take the last 5 remainders. So fine. What I did is I just started from like a to the b minus 20 mod mod, and then I went through the brute force again. And then in part three, it says give me the sum of the remainders, which is a little trickier because sort of naive algorithm is like O of x, or O of uh, the exponent, but we're given pretty large exponents here, so we can't really afford that. Right? We can't like iterate through all, 1 to this large number. So what I've done instead is looked for a cycle, because if you look at this data, you can see the mods are actually not that big. It's like a few thousand. And once we get to sort of a whole state is determined by or like score modulo m. So if we see the same m again, like the next 100 iterations are all going to play out the same. So we keep track of, for every number that we've seen, what the time and the answer was when we saw that number last. And if we see a number twice, then we can sort of accelerate the computation. We can say, okay, if we did another cycle, like every cycle that we do from here, it brings us back to the same spot. It increments t by this amount and answer by this amount. So let's do a lot of cycles so we get close to the limit, and just increment the answer by that amount and t by that amount, and then we don't need to sort of manually compute each of these numbers. We can just, because we know that every iteration of the cycle takes us back to the same spot. So we can just loop around the cycle many times until we get close to the limit. And that is what I did for all the parts. That's it.